Okay, full screen here. All right. So what I thought I'd start doing is centering the board, the screen. All right, is just practice on some of the things that I laid out in some of the earlier videos that are posted on the channel. Doing a lot of work with cubics lately. You're going to ask my class to do a little project on them. So reps are real important in math. Getting a lot of reps is important in anything you want to learn how to do. You want to learn how to do it quicker and more easily. And you got to do it a lot of times. So I'm going to do 5 graphs in a row here. Show you how quickly and easily you can graph a cubic without a calculator. I've got easy integer numbers to work with, so that if you have more difficult cubic, you can certainly put it in graphing calculator or online grapher and validate your answers. So 5 practice problems are coming your way. Supporting videos of what I'm going to practice in a moment on the channel, completing the cube, putting cubics in graphic form, geometry to algebra to calculus in 20 minutes. All of these things spell out what I'm about to do and why I can do what I'm about to do. And a geometric view of integration, I think, is worthwhile watching if you're going to be taking a calculus class. Be nice if you understood what you were looking at rather than just working with formulas. All right, so these are the 6 shapes that cubics come in. When the a term, the coefficient of x cubed, is positive, you get one of these 3 shapes. And if it's negative, you get one of these 3. I'm going to do 4 when a is positive. I think it'd be easier to get a handle on what I'm about to do if I stay with a positive first coefficient. And I build a little bit of difficulty into it by increasing the value of the coefficient. But the relationships are based on minus b over 3a, which I'm going to try to maintain user-friendly numbers. The graphing form for a cubic is as follows. Right here, where h is minus b over 3a. All right, so that'll get you the x value of the point of inflection. The rate of change at that instant comes from the formula c minus 3ah squared. So it's not hard to get the rate of change at that location quickly and easily. And the local maxes and mins, if they exist, can be found by this formula. X equals h plus or minus the square root of minus m over 3a. And explanations for all of that are in the supporting videos. So you got to do a little work if you're going to get quick and easy with understanding cubics at a little deeper level. And so now I'm going to just go ahead and do 5 problems in a row. And I've already written the first problem out, save some time on the video. And this is going to become the graphing form. And I'm going to find it shortly. But you pause the video on each of these and then follow, do it yourself and explain it to someone else. Are the 3 stages of learning. So maybe it's just follow for the first couple, and maybe by the 3rd or 4th, you can start doing it yourself and garner some understanding and have some conversations with classmates about cubics. All right, so let's have at it. I'm just going to sketch this. Now, I'm not going to draw an x-axis because I don't know about the roots at this stage, but I'm going to find the point of inflection, the rate, the local max and min, get the general shape, and I got a little better feeling for this cubic. So the first thing I'm going to do is start with the y-intercept of -5. So 0 gets me -5, and I know at this instant, I'm going up at 10 to 1. I'm going up at 10 to 1, and so now I got to find the point of inflection, because this could always be increasing. It might have local maxes and mins, I don't know yet. So I'm going to find minus b over 3a. In this case is minus 3 is positive 3 over 3 times 1. Nice, easy number to work with. So at 1, I have a point of inflection, so I can write -1. I can plug 1 in. If I do, I see a nice 3 to 1 ratio, opposite, plus 10 minus 5 gives me 10 minus 8, 2 plus 1 is 3. So this function is probably always increasing. And at 1, I'm at a height of 3. So I'm building off of the coordinate 1, 3 and looking at change. And so m, I'm assuming the slope c minus 3ah squared. I'll leave these on the board. So in this case, c minus 3ah squared, c is 10. Minus 3, a was 1, h was 1 as well. And it looks like I'm going up at 7 to 1. It's the quickest, that is actually the least quickly, the smallest slope of any tangent is occurring at the point of inflection. And so that's just a rate. I almost wrote it as coordinate. So I can now put that there, and I can see that there are no local maxes and mins to be found. But that's the graphing form. Obviously, you don't have to write that. All right, so that's the first one. Let's tackle another one. Second, so I can leave that right here. I can erase that because I don't know it, and I can erase that. All right, and this because I don't know the next one. But y, the second one is 2x cubed minus 18x squared minus 10x plus 5. All right, so let's erase this. Y-intercept of 5, but in this case, I'm going up. Didn't want to do an x-y axis. So 0, 5, 0, comma, positive 5, yeah. Going down at 10 to 1. Okay, so I immediately know that this is going to have some local maxes and mins. I may not be drawing to scale here at all. Bear with me while I erase a few things. All right, so minus b over 3a, 18 divided by 6. 18 divided by 6 is 3. So I know that somewhere down here I am, and I didn't draw this to scale. It should be symmetric. Local max and min should have some symmetry. But let's put 3 in. 27 times 2, 54. So this should be 3 times that, 162. And it should be opposite. You check it. And if it's not, oops, I forgot to write the x. 3 times this minus 30 plus 5, 192 plus take away 5 is 187, take away 50, it was 137 divided, take away 4, 133, I believe is minus 133. Part of learning to, working with math is taking time to make sure you're not making a mistake. I'm not taking any time here. So if I make a mistake, just write a comment, tell me I added and subtracted wrong. All right, so now I got to find C minus the rate of change at this instant, minus 10 is C, minus 3A was 2, I believe, and 3 squared is 9, H squared, and so minus 10, minus 54, minus 10, minus 54. So I'm going down at 64 to 1. This was minus 133, and I'm going down at 64 to 1 at that instant. And now I can find the local maxes and mins. So this is going to become H minus the square root of minus M over 3A. H we know was 3. I'm building this off of that location. Minus a minus 64, was that right? 61, 64. So it becomes positive 64, and 3 times 2 is 6. And if you worked with that, and I'm sure you can make that simpler to understand what that number is. That's the local max, X value of the local max, and the local min would be 3 plus square root of 64 over 6. Okay, and then you got your local max and min X values. Not friendly, not going to drop them in and do that math. All right, so that's the second one. Let's get another one. I do a coefficient, a negative coefficient on the last one. But I think getting the handle on this would be easier sticking with A values that are positive. So again, I'm doing 2x cubed. So I immediately have that. All right, I hope I put it there on the last one. Might not have. 18. Negative 18 divided by 6 is negative 3 this time. So I got to write plus 3. Plus 3. C minus 3AH squared is that multiplier. So C in this case is, yeah, you can see this is 10 minus 3 times 2 times, what did we say it was? Negative 3 squared. All right, that gets me 10 minus 54 again, which is, yeah, minus 54. 10 minus 54 is minus 44. So I now know I have one of these things. I won't even put the y-axis there this time. And I know that I'm decreasing at 44 to 1 at this instant. And I know the coordinate for that is minus 3, comma, negative 133. Hope I didn't make a mistake with this. Hope I didn't make a mistake there. And now we have our maxes and mins for the local max and the local min, the end behavior here. I hope everybody has had discussions about end behavior already. H was -3. This is this X value right here. -3 plus the square root of the rate of change, positive. So that becomes positive 44 over what? 3 times 2 is 6, and that's that X value. And over here, it's -3 minus the square root of 44 over 6, which could have been written as, 4 root 11 over, well, this is inside square root of 6. So I guess I reduce that to 22 over 3, get a little better feel for, the size of that. And then you plug it into the calculator, get your right one. All right, so did I list it up here yet? No. 44 over 6. Put that in parentheses. All right, so that's that one. All right, I should have changed M to -44. I forgot to do that, but this is just practice. So now we're going to look at 3x cubed. 3x cubed plus 9x squared minus 10x plus 5. I think it's better that I put this here. All right, so again, I don't know the shape yet, so let's do minus b over 3a. Let's get that out of the way. So minus b, -9 over, oops, I better change that. Otherwise, we're going to be working big time with fractions. Oh, no, 3 times a, excuse me, just 3 times 3 is 9. So I'm still giving you something that's pretty easy. All right, so -1, so x equals -1 is where this is going to have a point of inflection. And if I plug -1 in, we can do that now here real quick, -1, so that's -3, that should be 9, positive 9, a 3 to 1 opposite relationship. Yes, it is. A negative times a negative is a positive 10 plus 5. And so I'm looking at 24 minus 3, I believe 21. All right, and the rate of change there is c minus 3ah squared, if I get familiar with that. And then we'll put it in graphing form and sketch it. So m minus 10 minus 3 times a was 3. H was -1 squared. So that becomes, I believe, -19. So we definitely have one of these because at the point of inflection, we're going down at -19 to 1. And that occurs at -1 comma, we put it in 21. So my y-intercept is going to be here. A 0 should get me something smaller than 21. Oh, it does. It gets me 5. And at this instant, I'm going down at 10 to 1. Again, the supporting videos explain where all of these numbers come from. And then we have our h minus the square root of minus m over 3a is going to get me that x value. So let's do it now quickly. H we know is -1 minus the square root. I'll do a little bigger here. What did we say? Minus 19. The opposite of minus 19 is 19. And 3 times 3 is 9. So you're near the square root of 2. Near 1.41 coming out of this. And that's going to be our x value here. X value here is going to be -1 plus the square root of what? 19 right? And I know the square root of 2 in trig 1.41 roughly. This is close to 2, so you're approximately -1 plus 1.41. Gets you a feel for, that this local max is just slightly to the right of 0 on the x-axis. That number is. All right, so it doesn't hurt to have a little feel for the number. And the last one we'll do, and then we had 5 practices, which hopefully moves the needle for you a little bit in your understanding of cubics. So this time I'll do a negative. So y equals, let's put it here, and then I'll put it in graphing form. Minus 2x cubed, I think I forgot to put it in graphing form, so we'll do it here. 12x squared plus 7x plus 2. All right, so I know I've got that. I know I've got that. I know I've got that. And now let's find the point of inflection. Minus b over 3a gets us the x value. one more time hearing that. In this case, minus b minus 12 over 3 times negative 2 is a positive number, and it's 2. So I can write minus 2, minus 2. Now I'll drop a 2 in, 8 minus 16, so this should be positive 48. Take your time with it and see that it is. Plus 14, plus 3. And what do we got? We got 58, 62, 65, 55, 49. So positive 49, I believe, is what that is. Write to me if I'm wrong. Let's look at the slope, add the linear component, just real quick. This gets me, well, I didn't say I practice it, look at the supporting videos, but really what I'm getting is a cubic that has no rate of change at the point of inflection with a linear function whose slope we're about to find. So C 7 minus 3, A was negative 2, and H was positive 2, so 2 squared. And so that's 7 plus 6 times 4. So 31. So I'm going up at 31 to 1. That means I know now that I have a graph that looks like that intersecting the linear component there, which is going to get us a graph that has local maxes and mins. So let's find that. So 24 plus 7 is 31. That's the graphing form. I'll just do a real quick calculus for those of you studying calculus. So take the derivative of this, get you minus 6x squared plus 24x plus 7. Take the second derivative, so that's your first derivative. Take your second derivative, which is minus 12x plus 24. When does that equal 0? Is when you're changing in cavity. And we can see x equals 2 validates this. Okay, and if we put 2 in here, we should get a maximum, right? Because that's where this is going to be going up the fastest. Coming down, going up, coming down. I'm going up fastest right there. So that should occur at 2. 48, so cut that in half, 24, 24 plus 7, 31. So that validates our rate of change at that instant, right? And 31 is going to get us a y value of max. Just to show you connecting it to calculus. And so what do we have here? We have 2 gets us, I hope I wrote it down, I did, 49. And my rate of change here was 31 to 1. I'm going up at that instant at a rate of 31 to 1. So now I have h plus the square root of minus m over 3a. I hope the reps are starting to do what they do. In other words, make it easier for you to work with it. So what's h in this case? 2 plus the square root of 49. No, it's 31, wasn't it? 31. So the opposite of 31, which is minus 31, is getting divided by negative 2 times 3, which is negative 6. And you can see we have real roots. Not real roots, real local x values for max and min. So this x value here is 2 plus the square root of 31 over 6, near the square root of 5, a little bit bigger than 2. And so this one over here is going to be the x value here is going to be 2 minus the square root of 31 over 6. And we got a lot of information at our fingertips. All right, so that's 5 practice problems. I'm going to start doing 5 practice problems of graphing quadratics quickly. Certainly exponential, log, sinusoid, so on and so forth. Just going to get 5 quick practice problems and try to show you the shortcuts in each situation. All right, and so that's, you want to get better at it, you got to practice. All right. Toodaloo.